Hello everyone, and welcome back to Visualizing Operational Informatics Data using R. This hands-on exercise is on shinydashboard. The preparation includes installation of packages shinydashboard, and DevTools, and you also need to install rCharts. Step 0. Run the provided source code. When you open your hands-on shinydashboard FD file, you should see the following source code inside of it. First, we load the packages into memory. Then we prepare data for visualization. And then you start seeing the shinydashboard objects. First, it's the UI, and then the server. The UI object is created using dashboard page function. That function takes 3 arguments: dashboard header, dashboard sidebar, and dashboard body. You can now notice that dashboard page is almost like a Russian nested doll with arguments that are also functions. Each of these functions takes more functions as arguments, so make sure you separate them with commas. The server function is a nameless function that takes input and output objects and is not doing much at the moment. You have to combine the UI and the server inside the Shiny app function to display them in the viewer. Let's try that now. We select all the code including library calls and data preparation and hit run. Now this is a little bit deceptive because I'm all zoomed in RStudio, so you can't see the UI properly. I will open it in the browser. Now you can see the UI. The 3 elements are the header on top, sidebar on the left, and the body right here. This is basically an empty canvas that we will use to populate with charts and other objects. Normally, you would separate the UI and the server in 2 separate files. However, for the purposes of this demonstration, we're putting them inside one file to make it easier for you. Let's get rid of these comments because we will be working with server and UI later. Step 1. Let's add a title and a content box to the dashboard. Content boxes control the layout of the UI and can be used for text or output of a plot, a table, or any value on the server side. We already provided some charts in rCharts hands-on. Let's use one of those for this box. You can just copy and paste the chart code from the exercise or the solution file. So our first step, going back to the hands-on and shinydashboard file, let's add a title on the header. We work inside of the dashboard header function at this moment. We type title and then the name of it. Let's call it Demo Dashboard. Inside our body, we'll have a content box. Let's open that function and create a box. This is also a function and it will be empty at the moment. We'll get back to it later. Inside of our server function, we will have to create an output object. The output object is a list-like object. So when you start typing the output, you separate its ID from the output using a $. Let's call this element PI growth chart. We assign it the render chart function. Output objects are created with all kinds of render functions. It can be render plot, render image, render table. For rCharts, however, there is a special function called render chart. Inside of it, we'll paste the code from our rCharts tutorial. I have that code selected right here. You can use the same code from your solution. Just highlight all of it for the time series and paste it inside of the render chart function. However, we're not done. To make it work, we need to add one more parameter to our PI growth plot. So use $, and then type add params. Inside add params, there is an argument called DOM, and we will assign DOM the ID of our output, which is this right here. PI growth chart. That way we're tying our chart and the plot together. At the end we have to return the plot, which is right here, PI growth plot, and now it's ready. We create a plot on the server side. Now we need to display it in our UI. We will open our box function, and inside of it call a function called showOutput. ShowOutput is a special function to display rCharts inside of Shiny. This function takes arguments as the ID of the output, which in our case is PI growth chart, and also the name of the library that you use to create it. We know that we used rCharts. Type it in all lowercase. And that's it. Let's highlight the code and execute it. But before that, let's stop our previous application. Now we're ready to execute this code. Highlight all of the UI, the server, and the Shiny app, and let's run it. Now you can see our time series chart inside our dashboard. You also see the new title we added, and the chart itself is inside of a box, which you can see by looking at this line on top. Let's stop the application. Now, to make it always appear in our browser by default, we can wrap this Shiny app function inside run app and add an argument launch.browser equal to true. This way it will always open in the browser by default. Step 2. Let's add an input widget. In order to demonstrate a simple drop-down menu, let's add another plot on the server side, which will take input from the user. The user will select a grouping variable from the drop-down widget, which will be used in the grouping the number of projects that CBMI worked on. Let's start by creating a simple widget. Let's assume that the new widget and the plot that we will use the widget for will be inside a separate box. For that, we will need to separate the first box from the second box using a comma, because they will serve as separate arguments to the dashboard body function. Inside the box, we will put the drop-down menu. In Shiny terms, the drop-down menu is actually called select input. The select input takes several arguments, as you can see here: input ID, label, choices, selected, and some others. We will use input ID equal to, let's call it group, because that will be our grouping variable. Make sure you don't have any spaces inside the ID. Next, we will label the widget. This is what the user will see. We'll call it group by. Now we also need to provide the choices for our drop-down menu. The choices will be a vector of application and funding type. Both of these are column names in our dataset. You have to make sure that you don't have spaces in these choices, otherwise you will have to use a different syntax to provide both the values and the labels for those values. The selected choice by default would be application. And this is it for the select input. Let's go back to our server code and create a new output element. Remember to separate the output element from its ID using a $. We type output $, and then let's call this frequency chart. We will use render plot function this time because we're working with the base plotting package in R. We will type render plot, and inside of it we will create a new variable that will be storing our input from the user. Let's call it group in all caps, and then we type input $, and the ID of our drop-down menu. The input ID of our drop-down menu is group. That's what we will put behind input. Now we need to create our plot. Let's call it freak plot. We'll plot ops data, and now we will select the column that we're plotting. It can be either application or funding type, and depending on what the user provided, it will be stored in the group variable. Let's copy it here. And also we want to give our plot a title, which will be main equal to number of projects. This plot will display the number of projects grouped by either application or the funding type. Next, we need to call our plot, and our output element is ready. The last step is to display it on our dashboard. Let's display it in the same box as the drop-down menu. So we will put comma behind the drop-down menu and start the output function. For the base plotting package, the output function would be plot output. You will actually use it for ggplot functions as well. The ID of our output is frequency chart. Now we can also specify dimensions such as width and height. Let's give it a height of 300 pixels. And that's it. We can select our UI, server, and run app code, and run it. On our Shiny dashboard, you can now see the time series on the left and the new plot on the right. As you can see, it's plotting the number of projects grouped by the application because that was a default choice in our drop-down menu. When you click on it, you can select funding type instead, and the plot reactively adjusts. Step 3. Let's add another widget to our dashboard. It will be a time filter, and it will limit the amount of data used in the time series chart. This example will also demonstrate reactive datasets in Shiny, which can be reused in several charts or other graphical objects. Going back to our code, let's stop the previous application. Now we want to add a new widget. Let's add it on the sidebar. Inside the dashboard sidebar function, add a new line, and let's add a date range input. Date range input, which takes several arguments. First will be the input ID. Let's call it date range. No spaces, if you remember. The label is what the user will see. Let's call it date range. You can add a space here. Inside the date range input, we also need to provide the start value and the end value. The start value would be 2012 January 1st. Make sure that if you provide a string value for the date range input, it's in the ISO standard. End value would be today's date. So let's type sys.date. Let's also provide the format of how the date will be displayed. Let's do month, day, and then year, all lowercase. As you can imagine, the date range input will return a vector of two values, the start and the end values that the user selected, or were used by default. We can grab those values by indexing the vector. Coming back to our server function, let's create the reactive dataset. We can name it first. Let's call it filtered data. We want to filter our dataset called PI cumulative growth, used in this time series. To create a reactive dataset, you need to use reactive function. Inside of the reactive function, let's subset our PI cumulative growth dataset. We will call it filtered PI growth, subset PI cumulative growth. We will filter it by month. So the month variable has to be within the start and the end of this date range input. So month has to be greater or equal to input $, and then the ID we used was date range. After $, we put date range. And then the index of the value. The start value is index 1. And month has to be less than or equal to the end value. And it's stored in input $, date range, index 2. Let's call this dataset. And there you have your reactive dataset. Now you have to understand that reactive datasets are essentially functions. So if we substitute PI cumulative growth with filtered data, we have to end it with a parenthesis. Every time the user provides a new date, this reactive dataset will be reevaluated, and the chart itself will also be reevaluated because filtered data dataset is used here. Let's try this out. Select the UI, the server, and the run app code, and run. As you can see, we have the date range input in the sidebar. Let's try it. Click on the start value, and you will see calendar. Click on January 2012, and then 2012. Let's start our time series in 2014. Click 2014, then January 1st, and our chart just adjusted. Now it starts in January and is all the way till March 2015. Now it's time to try adding charts and widgets on your own. You are given 5 minutes to try and add a histogram to the dashboard and also a drop-down menu as we did with the frequency plot. The histogram would visualize distribution of a variable in the ops data dataset, for instance hours logged or days open. Use the frequency plot as an example and then add a select input widget as we have with number of projects. With the two options, hours logged and days open, connect the input and the histogram together. Take 5 minutes to try this out on your own. Let's see the results. I prepared my solution ahead of time. Let's take a look and see if you have the same. First, on the UI side, we have a new box that contains select input with ID distvar, labeled distribution of, and choices hours logged and days open. The selected by default option is hours logged. Then after the comma, we have a plot output. We're plotting distribution plot with height of 300 pixels. On the server side, I created an output element called distribution plot, and I use render plot function with a new variable called var that stores the user input of distvar. And then I'm plotting a hist plot using hist function. I use the variable provided by the user to select a specific column that I will be plotting. It could be either hours logged or days open. And then inside my title, I'm concatenating distribution of string and also the user provided variable. And I'm also using the user provided variable as my X label. And then I call the hist plot, and that's it. Let's stop our previous application and see if this code works. Select your UI, server, and run app, and run. And it seems to work. We can see our new plot below, because by default Shiny Dashboard will allow two boxes in the same row. You can control that using the fluid row function and column attributes. But if you look at our plot here, we can manipulate using the drop-down menu what variable gets plotted. At the moment, it's hours logged. You can see it inside the title and also on the x-axis. Let's change it to be days open. The plot got adjusted, so did the title and the x-axis label. Step 4, and this is the last step. I would like to show you how you can separate your code into two files as you would normally with any Shiny application. You will have two files, UIR and serverR, with the UI code and the server code. You can also create a global R file which will be visible to both UI and serverR. Let's go back to our code. To separate the UI code into a separate file, we will select all of the UI code, copy it, and paste it into a new script. We will actually get rid of this variable and assignment sign and start our code with dashboard page. Before dashboard page, we will put the library calls because we want to load the packages into memory. Go ahead and paste all of them here. And this is it for the UI. We will save it. I prepared a new folder for my demo dashboard, and I will paste the code here. UI. Now going back to our code, let's select the server code, starting here and all the way here. Create a new R script and paste the server code inside of it. Now we're actually not done. We need to get rid of the server variable and assignment sign. And this function, this nameless function, will be wrapped inside Shiny server function. So make sure you include that on top and close it on the bottom. We also need to load the packages into memory inside this file so that we don't have any issues with performance. So let's paste the code here. This will not work by itself. We have to have data manipulation saved somewhere. The rule of thumb here is that you can put all your data manipulation code inside the server R file. Let's select our data management code from here up to the UI, copy and paste it inside the server R file. There are several places where you can include the data manipulation code. You can place it above the Shiny server function, and it will be executed once whenever you first run the app. If you place it inside the Shiny server function, however, it will be executed every time you run the app. So it's up to you where you place it. Let's save it as a server file. And notice that I also have a data folder for my datasets ready. You will reference the dataset inside the data folder from your server file as if it was in your working directory. So let's try this out. Let's stop the previous application and run this app. Notice that it works just as it did with both UI and server objects inside one file. And this is it for our hands-on exercise on Shiny Dashboard. We hope you enjoyed working with Shiny applications. Thank you for watching.